Hello and welcome to STARLIMS webinar series. On behalf of Abbott Informatics, I'd like to thank you all for attending today's event, ensuring compliance and efficiency through powerful instrument integration. My name is Caroline Araujo, and I'm a marketing manager at Abbott Informatics and will be moderating today's event. Today's speakers are Pradeep Nagisetti, Regional Sales Manager, India and Subcontinent, and Jason Chung, Business Consultant Manager at Abbott Informatics. Following the presentation, we will move into a live questions and answer session where you can pose questions to today's speakers. Please remember you can submit your questions at any point during the webinar using the questions panel in the menu on the right. We will try to address as many questions as possible during our time together, but if we run out of time, the unaddressed questions will be answered via email. Additional resources can be accessed via the resource window, also located on the right of your screen. And just to remind you, the recording of this webinar will be available later this week at Abbott Informatics website. I'll now hand over to Pradeep.
Thank you, Caroline, for wonderful introductions and having me today. Once again, good morning, good evening, and good afternoon to all the invitees. And welcome again for this much-awaited webinar. So I'm here to share my global and regional experiences being worked in labs for 10 plus years, and now at the other side of offering lab automation solutions from Abbott Informatics, STARLIMS. I trust this is best of the two worlds anyone can experience in this space and give it back to scientific community. With that, I'd like to jump into the quick recap of various lab automation solutions and what are the purpose they build for. So predominantly we see in the lab automation space LIMS, ELN, SDMS, chromatography data systems, and other data management systems. There are several others, but predominantly these are the solutions that most of you must be aware. When you look closely, the LIMS systems are built for master data management, sample management, workflow automation, reporting, and many other several modules. And ELNs are built for executing tests, methods, SOPs, keep track of various steps in the day-to-day lab practices. Whereas SDMS are built for very different purpose. Instrument data acquisitions, data storage, large data storage, archival, search, and communication, various communication mechanisms with the lab equipments and third-party systems. So chromatography data systems are built for a very specific purpose. There are very few in nature. They're predominantly comes with a OEMs, original equipment manufacturers, to manage the equipments and control the equipments and networking of those equipments into a single node. And also they helps largely in instrument data acquisition, storage, and archival. And you probably also deploy a lot of other IT solutions, infrastructure, networks, storage systems that you probably deploy as part of your IT and data management solutions such as data archival solutions, networking, backups, and DRs. But when you look closely, none of these systems can do everything that you can imagine them to do, or that anything that you can imagine from end to end in the lab automation practice. So precisely, no system is ever built for the best of the breed LIMS, ELN, and SDMS functions. In other words, one of the best practices today we have in the industry is to choose some of these best tools from each of these category and then integrate them in at a project level. Although it is not a bad choice, considering there is no best of the breed solution today in the market, but it does not solve 100% of today and tomorrow's lab automation challenges. This approach has never been so easy, considering the legacy SDMS systems limitations, both in terms of technology, functionality, and interestingly, their integration capability with your LIMS and ELN systems. So that is where today we're trying to address this challenge. What is next? where the whole world is moving towards the instrument integration by having some of these best of the breed solutions like LIMS and ELNs. Most of you must have already implemented or currently implementing. So when we talk about some of the common challenges in the current practice, I would like to recap. When I say the current practice, you buy a LIMS, you buy an ELN, you buy an SDMS, or you do not have an SDMS and you just have a LIMS and where you integrate with equipments with some kind of middleware. So some of the common challenges today, what we witness is it requires a lot of efforts in terms of time, cost in integrating your equipments with the LIMS and ELN because the LIMS and ELN systems are not originally built to integrate. They do not have a native integration capabilities. You make them to work, or vendors make them to work with the instrument integration. And most of the LIMS projects can fail due to integration challenges at later stage. And most of the data that today that is stored historically in your LIMS systems are more than 70 to 80%. It's a documents, equipment related data. So maybe less than 20-30% is your transactional data, which is more related to the sample. So in other words, the equipment related data, the documents, files, images, that actually clutters your LIMS database. But the whole purpose, the LIMS systems are built to handle the data that only retains only 20 to 30%, which is more of a transactional, day-to-day transactional data. And also many times, the LIMS systems, we face a lot of scalability, performance issues, and you end up doing performance tuning. You invest a lot of money as in operational expenses, IT expenses, out-of-pocket expenses in order to optimize the database, tuning, performance tuning related issues. That is again due to one of the major reason is, your database is very heavy because that was not built to handle the instrument data. And also we've seen predominantly most of the customers usually avoid instrument integration with LIMS, and you still continue to call it as lab automation solution. And also you would never be able to achieve so-called the dream of paperless lab if you do not integrate your equipments with your LIMS. So usually I have personally witnessed most of the customers either push the instrument integration conveniently to the later phases or they never do it. Okay. And another last but not least fact, equipment integration in LIMS and ELN projects also required a lot of validation efforts. Usually this integration required more than 50 to 60% of total validation effort. So these are some of the challenges I'm sure each one of you must have witnessed, and all of you have faced these challenges quite often. And we all witness these great opportunities to transform the way instrument integration and data management aspects should be done in highly regulated environments. So I would also like to do a quick fact check today. Some of the common myths around how is it different from interfacing equipment with LIMS, CDS, and ELN. This is a common question, or this is a common, the self-satisfaction that most of us have in the laboratories today. I've already integrated some of the equipments to my native system. So how does it matter? So when you look at it closely, many companies feel confident or sometimes overconfident that instrument data from the laboratory is protected in each instrument system, such as CDS, UV, IR, mass specs, and your CDS systems, and then is successfully transferred into LIMS manually or via a system linkage, which is nothing but an interfacing capability. And most of us believe that it is enough control of the data and no further action is necessary. So that's one of the biggest myths that I would like to bust out today by showing you some of the facts in the coming few slides in the next few minutes. Also, I would like to bring it up a few other questions to you if you have never faced them or you never thought about those, while you think that linking your equipments with LIMS or CDS or ELN is good enough. So some of the questions that probably is right time to ask to yourself and to your good laboratory practices is, have you ever processed data on the system of record? How many systems and times does your IT take backup files from the various sources? So it predominantly comes from what is your IT data backup policy, how many systems they continuously monitor on a daily, weekly, and on every minute basis. And have you ever had a version mismatch of processed data on the reported data? If so, how did you handle them? Once the data is already in your LIMS, so you cannot really avoid having them stored in your database already. So, and also how many subsystems do you have today in your laboratory, such as, once again, CDS, UV, LIMS, network folders, backups, DR, and many other intermediary folders that you currently maintain, and then you spend a lot of time and efforts and resources to find them, to search them, and also in terms of having them located as well when you need it. So this is, in other words, there's a lot of data lakes that you see very often in most of the laboratories. And what if your LIMS or CDS system is down? So it's inevitable sometimes. Is probably your LIMS and CDS is down, and what happens to the data produced by equipments? If you have if you're heavily dependent on your LIMS, how do you really handle the data that is produced by the equipment? Where does it go on a daily basis, right? So these are some of the questions and that needs to be asked on a regular basis whenever you plan for your lab automation and instrument integration capabilities. So let's look at it. Also, the other fact is how many different systems, when you have an auditor, internal, external auditor, how many different systems that you take them through, what kind of impression that you leave with them when you take them to the multiple systems for a very different data sets. What happens to, what kind of impression that you leave with. And also, I would like to also bring up another context here. There are several legacy SDMS solutions in the market. I wouldn't name them, of course, but it is important for you to realize where do you stand today and what is expected in the future, both by your organization, your best quality practices, and by your leadership, and most importantly, the regulatory agencies. Let me quickly run you through the three types of customers or three types of business scenarios that we can imagine today in the market. You can be very manual and still be doing a wonderful job by having a lot of papers, taking the prints, the data coming out every minute, every other minute coming from the equipment. So maybe taking a lot of prints and file them, put them into a boxes, and archive them into a big storage rooms. And what happens with this is you have a lot of manual data entry, and there is also potential data loss in terms of natural calamities, the fire accidents or anything that it's beyond our control. And also it leaves us with the highest or more potential data non-integrity challenges when you do a lot of manual equipment's data management. And also it leads to a least efficiency. You probably is not using your best resources for the right job in the laboratory, and obviously required a lot of turnaround time. And also you all end up spending 70 to 80% of your day-to-day job preparing for the audits, both internal and external audits. So this is one kind of common customers that we see in most parts of the world. And we also get to see, I would call them as semi-automated, or this is the most current practice in the market today. I would say 80 to 90% of us currently falls under this category, where you have a kind of LIMS, or you may have an SDMS, or you may have a CDS networks, or you use a combination of all these tools to do the equipment integration and data integrity aspects. So what happens in these cases is they're good. They're the only available solution today, as of, if you look at it in the last 5 to 10 years, but they also leave a lot of gaps in terms of data storage in local networks, because most of these equipments push the data into local networks. And then by the time your SDMS or LIMS pick up the data, there is a potential threat. Anybody can have an access to these networks and then tamper the files or tamper the data available. So there is a lot of IT infrastructure related challenges to manage the data that is produced in the local networks. And 50 to 60% of equipments are interfaced. So when we looked at it closely, from our experiences in the last 36 years, so most of the companies have managed to integrate only your 40 to 50% equipments because of native LIMS challenges, because not every LIMS is built to interface with every type of equipment out there, because there are new innovations and there are new equipments, there are new interfacing methodologies that have been discovered in the last few years. So how do you really keep pace with those instrument interface challenges? So that's where we see is an average 50 to 60% equipments are what is being interfaced in most of the lab automation practices. And we still have multiple systems to implement, validate them, be it a simple IQ or Q validations, or it can be a very serious CSV, computer system validations of multiple systems, and train the end users on multiple systems and maintain and upgrade them on a regular basis. So that's still a major challenge with the current practices. And you also have multiple systems for audit facing, and also some of the deep problems are these systems are meant for taking only the process data or the files that are generated at the end of the runs. So what happens to other data such as the raw data, the audit trails that are produced by equipment, the run reports, intermediate reports produced by the equipments, they just are left behind in those native systems and then taken as a backup into the other backup or IT backup as an IT backup, but they never been handled as one's single practice. And also, since I already covered this point, since you dump most of these files as they come out of the equipments and then you straight away push them into LIMS, and predominantly the LIMS systems are slow and they suffer when you scale up, or when you scale up at a global scale, or when you implement it across your organization and enterprise scale. These systems tend to die both in terms of performance and as well as response time. That's one of the major challenge with be it a local or some of the global LIMS systems today. And also we have witnessed customers facing challenges with support and upgrades of these multiple systems and taking regular backups and implementing your IT policies on these multiple systems. So it's precisely, you still have a lot of systems, at least 6 to 7 different systems to manage, but you still don't achieve anywhere close to 90% plus in terms of equipment integration and data integrity aspects. So that is where we see a huge gap in terms of how this is handled so far and how better it can be done in the future. So what we strongly recommend, or what we have it ready for you to address some of the challenges is we have one of the most modern SDMS technology for a while. We are trying to repurpose this for the several business users, both in terms of those who have an LIMS, those who do not have a LIMS. STARLIMS SDMS can be a one solution that can handle all types of equipment interfaces. You can go up to 90 to 100% equipment interfacing capabilities. You can potentially avoid local network storage. We have a native capability to capture the data from the original equipments they are produced. In other words, we can absolutely address the Alcova principle in equipment integration aspect. And interestingly, we have designed a system in such a way that we hardly have 3 to 4 end user screens. So it's very quick both in terms of training, implementation, adoption. You do not have a lot of user interface. This is more of a technology tool, works as a middleware. So you end up doing a lot of validation, user trainings, and adoption. And we also have a system that can handle both raw data, process data, and all kinds of data that is produced from an equipment, from a sample preparation to the results generation, and during your calibrations and all other aspects of equipment management. And interestingly, the way that we have designed this system, like any other SDMS, you do not have to replace your current LIMS. We have an ability, we have designed a system in such a way that it can be seamlessly integrated with any of the LIMS system, not necessarily STARLIMS. As I said, it can be a very good middleware. If you already invested in any other LIMS, SDMS can only be add-on tool, STARLIMS SDMS tool, that can make you 100% future-proof in terms of equipment integration and pushing the data back to your LIMS and ELN systems. And also, in other words, we are helping you, keeping your LIMS, your native LIMS lighter, faster, and you can upgrade them easily, you can maintain them easily, and eventually you will achieve the highest efficiency in the laboratory, turnaround times, and highest data integrity possible today. So you are always prepared for the audits because all the data is sitting in one single storage system across the locations, across the instruments, be it any type of the data that comes out of your equipments. be it both inputs and output of the equipment. Jason would be running you through a deep dive into what kind of files are handled, how the interfacings are done, and how the data flow is about. So hence, we strongly recommend a SDMS solution that is very powerful, offers very high integration capabilities, and most importantly, can be scaled up to your full-scale LIMS in future. You may start with a small SDMS rollout, and then eventually you can scale it up to full-blown LIMS in case if you do not have a LIMS. And most importantly, it is an affordable because we understand the global and regional markets. We have our presence in more than 40 countries, including both developed and developing markets. So we truly understand the markets, and it's affordable solution. And a very quick implementation timelines is what another assurance from our side. And also it's easy to maintain and upgrade in future. So this is precisely some of the key functionalities what STARLIMS SDMS solution, enterprise solution helps you with instrument interfacing. Instruments can be various types that would include, your simple standalone equipments to CDS equipments, file-based. It can be unidirectional, bidirectional instrument interfaces. So we have an ability, we have the drivers ready to interface with majority of those equipments out there today in the analytical lab, R&D labs, formulation labs, and across the different industries as well. We also help you, quick turnaround time. At least we have witnessed a 5 to 10% quick turnaround times have been achieved, right from capturing the data from the instruments to PT of the labs. And it's also designed as an enterprise application. While we call this as a standalone system, it is standalone system by nature, but it works on an enterprise scale. Having it, the data can be stored across the locations, and we have a role-based access to the data that is stored in the SDMS database. And it can be, the role can be site-specific with a predefined permission. So very similar to your your LIMS or ELN systems, how they works on the role-based access to the data. And also it helps as a one single data storage and retrieval system. And most importantly, we also have a very unique feature called workflow routing. So this is another very unique use case. When the data is produced from your equipments, before the data is pushed to your LIMS, you have an opportunity to do an additional QC checks. You can do reviews, re-reviews, approvals, mechanisms you can deploy using a workflow component, and then decide whether data should be, resides, or whether you need to do a rerun reflex testing, or should the data go back to your LIMS system. So that's one of the major, demand from the market that we witnessed, from the data acquisition to, data is going into your LIMS system and showing against your samples and batch IDs. This is, very unique offering again. And last but not least, cost saving in terms of you can avoid investing on a multiple data storage systems, multiple data acquisition systems, maintaining, upgrading those multiple systems. So we can see definitely a 40 to 50% cost savings straight away, both on CapEx and operational cost expenses when it comes to data acquisition, data management, and data processing side. So that precisely is what today the STARLIMS SDMS enterprise scale solution can offer you. I request my colleague Jason to run us through the SDMS architecture, the data flow, integration capabilities, and other features that STARLIMS SDMS solution can offer today. Thank you once again for your time, and Jason, over to you.
Okay, thank you, Pradeep. So what I'll do is to talk us a little bit about the STARLIMS SDMS architecture. So in this diagram, I'll be covering different aspects of the architecture itself. As you can see, as part of the SDMS standalone solution, SDMS is in the middle of this diagram. On the right-hand side, you should see the various laboratory equipment that generates the final data to send to the LIMS. The purpose of this diagram is to show how SDMS not only captures the data from documents and various binary data files, but also acts as a middleware for direct connectivity to your analyzers and all the other laboratory instruments. So let's work on the file integration piece. For the file integration piece in the top right corner, we can see the various files from different instruments, whether they're PDFs, CSVs. And I'll go into this in a bit more in detail later. What you can do is push them to a network folder, which is highlighted by the shared folder part. And you can also see a grabber. That is our SDMS grabber, which is actually a polling application that just checks the location on the defined server. It could be a shared folder, to see if any files are being uploaded. And we'll move on more on this piece later. You also see that there's a box there called folder packer. Just coming back to these instruments, before they generate these actual final results data, they use some intermediate data files. So sometimes these are proprietary. And these files are actually on multiple instrument PCs. For both regulatory and GAMP5 requirements, these files need regular backup. Currently, it could be a situation that our customers or you could need to back up every single instrument PC on a regular basis, which is pretty much an administrative nightmare. Now, if this is automatically archived to a centralized location, it would not only minimize IT, but also operational costs to our end customers. Now, to meet this need, our SDMS has a folder packer utility, which is pretty much a standalone console application, and it allows archiving of that folder or folders and its contents. It monitors the source directory for changes. And once those changes are detected, or it could be on a scheduler base, so it could be during your off-peak hours, it packs up the directory and it moves the contents to the grabber incoming folder, which is then uploaded into SDMS, which becomes a central repository. The benefit of having this auto packer, folder packer is basically for your raw data archiving. Not only that, it can handle raw data restoring and also any time-controlled data archival of documents. And it's based on your original instrument file structure in a regulated, in a regulatory compliant repository. So in the case of an audit or when you need to retrieve that data years down the road, they will still be available. Let's move on to a little bit more about the SDMS solution. Let's think about alternatives, okay, to the shared folder. We also offer the virtual printer interfacing with SDMS. What this is a way of setting up within your architecture to set up a Windows service application that can be used as a shared network printer, which basically all the workstations can access directly, or you can install it as a printer for a single workstation. With this, you don't have this intermediate shared folder, and with this virtual printer application, you can print directly to the SDMS, and this is subject to your IT policy. Just slightly above that, let's think about when we talk about data acquisition of GMP data, let's not forget about your serial devices. For your serial devices, such as your balances, your pH meters, these are all important data. And the use of a TCP IP converter, we also allow some supporting external mobile applications, or you could use the STARLIMS mobility solution to satisfy the capturing of these results from such devices. And we'll get into more detail in a second. And this is all around automation, reducing paper, improving your data integrity. Now let's move on to the left-hand side. Now, getting that information into SDMS, that is the part of the actual solution. But as Pradeep has mentioned, it can act as a middleware and push this data out to any other LIMS system. So on the left-hand side, we can look at the events and triggers mechanism, how we push these events data to the LIMS. So once the information is captured within our SDMS, we can look at the way how SDMS can raise events that can be transmitted to any generic LIMS. So it can be through HTTP or it can be a local script. Now, this supports security tokens, for authorization and for authentication purposes. Enables the pushing of data via HTTP posts, and also pushing if it's not web-enabled, you can push data via local script or programs, and these results, these balances, these weights can be as data as arguments. Now, there are multitude of events that can be raised. So whenever these documents are received as part of the SDMS, when they're parsed, either have an error or have a success flag raised, when the document workflow has actually finished, or when the document is recognized by the SDMS, or even when any revisions are made to these documents are added to the SDMS, and this goes on. One example to integrate with your own LIMS system, okay, from your own generic LIMS, there will need to be some HTTP endpoints for SDMS to invoke. The methods to either check the connectivity from the SDMS to your LIMS before sending out any events data. And you could have similar endpoint URLs, how you would receive and process individual events data. That's the top part. The bottom part is the API. So we already have some published SDMS APIs. So most of the SDMS functionalities are exposed as web services. So as for any third-party system, whether it's LIMS and so forth, you'll be able to exchange data and services. So the set of web services available in our actual SDMS is actually very rich. And all of those services which are already needed for any third-party integrations are already available. So different types of endpoints, they're actually either SOAP-based or REST-based. So most of the SDMS services are SOAP-based, and this includes integration services, which are typically meant for the third-party LIMS systems, and designer services, which are probably more internal. While most of the operations are SOAP-based, there are quite a few that are REST-based, and typically those that are related to uploading and downloading the files. So if your LIMS system needed to extract some of those information or download some of those files from an SDMS, those APIs are available. And with web services in general, for any enterprise system, our SDMS is a secure system, so it will need valid credentials to be presented with each request for the SOAP and REST protocols. So let's move on to standalone and port-based instruments. So let's think about within the lab, within your paper-based systems, if paper printouts are used for your balances, the data eventually must be transcribed to the LIMS at some point later in the workflow. So it could be some sort of delay because it needs to be transcribed, and potentially you could be introducing human errors in the transcription process, which could require rework later. Not only that, let's take a moment and think about where work usually happens in the laboratory. So have you ever started working on something in your desktop, on your bench, and then having to go to another area of the lab where all the balances are placed, right, to continue the work? At the same time, due to floor space, you might not have a desktop next to each one, so you can't do immediate transcription. So one of the challenges working with serial devices would be the portability of the solution. So you're not restricted to a single workstation, to do the mapping of the weight results or pH readings from a simple device, to the sample ID if you're working with a LIMS. As part of the solution for the standalone or for the port-based equipment, SDMS has an underlying technology layer that will allow pass-through of data from serial devices to tablets or mobile devices directly to the SDMS. With this layer, middle layer, SDMS can pass the data and via another mobile application, for instance, perform the mapping between the related results to the metadata from the external LIMS. And eventually, the events triggers mechanism mentioned on the previous slide will allow pushing of this information externally and eventually to say instruments results table in LIMS-DB. So this is how it looks in the back end. So let's keep it simple. Let's look at the front end. So let's think about any mobile solution, or it could be STARLIMS mobility. So laboratories can really address these challenges that I just mentioned with the use of a mobile solution by connecting to the SDMS. For example, with a mobile solution, you can log into the SDMS, view the balance data on the screen, with the metadata pulled from external LIMS or third-party systems, such as the sample ID, the equipment ID, test code, any parameters that you may have, you can map the results from the serial devices before pushing onto into the SDMS. Let's move on to file-based integration. So for file-based integration, the SDMS includes various dedicated parsers for the most common document types, such as PDF, Word, DOC, DOCX, plain text, your text files, your CSV files, Excels, okay? So these are all covered. And just to consider this workflow within this diagram. As soon as it comes from the instrument itself, there is the grabbing part. So after the document is uploaded using the grabber through the shared file, or even the print to PDF, the print to the SDMS, the system attempts to recognize it. So what we do is, based on different meta tags values in the document that uniquely identifies the document. For the example, an instrument ID can identify an instrument type document, right? The next part of it is the full parsing. When a new type of document is uploaded, and after we've trained the SDMS, what we can do is the SDMS can parse the files automatically using some sort of pattern matching logic and algorithms that are really independent of the knowledge base or the dictionaries. And there are two different parts of this. There's the file recognition pattern, which includes the metadata, the file types. It could have pushing to a workflow. And when you upload similar documents, and it would be the case of instruments of the same type, the system would be able to find those meta tags in its database, and it will recognize the relevant file type and the workflow. And then we have a second type, the document recognition pattern. What we can do is then extract those keywords. So on a PDF or on the CSV, it can look at the headers, it can look at the instrument ID, it can look at the operator, it can look at the dilution or the method. So these are all keywords. What it can do is look at the results, and it can also look at any chromatograms, these tables and graphs. And what it does, it transforms this raw data from this unstructured format in this file base into the XML structured format. And not only that, for all parse documents and any raw data files, indexing will be performed, and it will be stored in the file server component. So regardless of what goes into the SDMS, everything will be indexed. And eventually what we'll do is map this data to the UXML, Unified XML. And I'll cover this a little bit in a second. So the SDMS extracts the static data to this Unified XML structure to export, and so you can reuse the data. And basically the system can reconstruct these documents and all their elements, etc. And not only that, all the file-based records that are within the SDMS itself, which is instrument it came from, where all the keywords that are parsed out of it, are all within the SDMS database, which opens up the possibility for data analytics. So as I mentioned, UXML is a very useful for exchanging data with LIMS and other systems. When the SDMS recognizes and parses the files, it saves the extracted data as UXML. And there are several advantages. It's text, it's portable, it has a structure, so it's easy to find the exact piece of information on any document. It's consistent, so no matter the format of the original file, PDFs, docs, text, CSVs. So it becomes a structured denominator representation, and it makes it possible to extract this data further down the road. So looking back at how what we mentioned about workflows. So let's focus on the data review workflows. So this SDMS is basically a centralized repository for all data acquisition for a laboratory, whether it's file-based, whether it's serial devices. And also at the same time, as being a document management system, we can highlight several important features as part of the SDMS. It stores all the types of raw data in raw and processed formats using the advanced indexing capabilities. You can retrieve this data using the advanced searching capabilities and using the indexing capabilities. It also provides a workflow design and management. And it also, at the same time, supports retention policies, which is very important for our customers, with customizable approval and sign-off processes. So if you would like your document, for instance, or your results to be retrieved by other users, right, you can link that document to a workflow and require certain steps, which includes creation of the document, reviewing of the document, modifying, say, revision of the document, approving of the document, and finally exporting the data to other systems and other actions it could be possibly. And permissions are assigned to the individual users for each step of the workflow. So here you can actually see a screenshot of the Workflow Designer window, which allows you to create new workflows or edit existing workflows. So the Designer is a graphical tool. It's basically drag and drop that allows you to build and visualize the workflow using boxes, the squares that you can see, logic operators. So you see the and, the ors, etc. And these are all connected by the actions. And you can use these logic operators to determine if all of these steps are required or there are some steps that are fulfilled and then it can progress to the next stage. So in this example, you can see the document is created in SDMS. It's followed by a review step, and then it's followed by an approval step. Eventually, that file content in the form of a UXML is then passed on to our events and triggers mechanism. And from there, you can push it to an external system. And it also can be retrieved using the APIs. So I just want to close my part of the presentation. I would just like to mention other features that are available in the SDMS standalone that we haven't gone into too much detail. Our Microsoft partnership not only allows these workflow tasks mentioned just now in this slide to be managed not only directly in the SDMS application, 4 to 5 front-end screens, but we also have Microsoft Outlook plugins. So as you're using your Outlook, for instance, and you see these tasks coming in from the lab, you can actually do that directly within the same application. And all of these documents that are already in the SDMS database can be checked in, edited, and then checked out, and edited, and then checked back in. So really similar to a DMS. All the traceability related to that document workflow can be found within the workflow history application. It displays all the records of the performed actions, for example, when it was created, who reviewed it, all the different stages, any rejections or approvals of your instrument data is also within the standalone SDMS. So all of these features make it really possible to extract and perform data acquisition from multiple instruments using multiple formats, store in a regulatory compliant repository, and ultimately transfer or not, if you don't actually use another LIMS, in a consistent manner. So our STARLIMS SDMS is a web-based scientific document management system built on Microsoft technology. What I want to do is just show you a cool video that will summarize and also let you ask any questions after the video.
Innovation, flexibility, integration. They're at the core of what we do. STARLIMS SDMS, Scientific Data Management System, is now available as a standalone product in addition to a component of the integrated solution to help clients achieve compliance with the data integrity expectations of the Food and Drug Administration, FDA, as well as other regulatory authorities. STARLIMS SDMS can benefit three types of clients. Organizations purchasing the integrated STARLIMS Laboratory Information Management Solution, which includes SDMS. Organizations with an existing LIMS lacking SDMS capabilities. And organizations without a LIMS seeking a standalone SDMS solution to manage their data. Abbott Informatics designed this solution specifically to help organizations comply with 21 CFR Part 11 regulations to ensure compliant record creation, audit trails, electronic signatures, and data security. STARLIMS SDMS can identify and store equipment data files in native formats, parse data, include extracted metadata, and does not require availability of the original software to create the record. STARLIMS Standalone SDMS can work independently or with an integrated LIMS system to reduce the time to achieve data integrity. Even without a LIMS, the Standalone SDMS can capture data in real time, back up data, protect it from deterioration and loss, and maintain the raw data as the original record. You have the option to later integrate it into the enterprise STARLIMS or other service, and it can also work with your existing LIMS without replacing it. Find out more about how this solution can help your organization. 1. Enhance data integrity. 2. Require less validation efforts than replacing an existing LIMS. 3. Save on investing in additional middleware or multiple data storage systems. 4. Keep your LIMS lighter and faster without replacing it. One partner, one powerful solution. STARLIMS.
Great. So thank you, Pradeep and Jason, for the excellent presentation. We now have the pleasure to introduce our Q&A session, where we will address all your questions. Don't forget, you can still submit your queries via the questions panel in the menu on the right. So let's take a look at the first one that we have here. So I have been using, or I am aware of other traditional SDMS systems. How is this different from the others?
Okay, Jason, can I take this?
Sure.
Okay, so this is different in three major ways. So I would say this is one of the first enterprise system by design, unlike other standalone SDMS systems are, designed to be really standalone systems, the older technologies, I would say. And we are one of the SDMS system which is eventually can be scaled to full-size LIMS ELN, and then also can become a complete lab automation solution. You can start with SDMS, can eventually become a full lab automation solution. So that's one part of it. Second one is technology. As I said, this is one of the, I would say, to best of my knowledge, we are the only 100% HTML5 web technology interfacing tool today in the market on the SDMS, and can work equally good both on on-premise and cloud. And also we are only one of such solution who has data analytics and mobility functions enabled beyond just a traditional equipment integration capability. And last but not least, we have the largest professional services team who can take you to the end. Instead of just deploying an out-of-the-box SDMS system and then train you and run away, we would also be able to understand other LIMS systems and SAP, ERP, DMS, and QMS system, be able to integrate them and make sure they all sit into your enterprise IT architecture instead of SDMS being just a standalone system sitting in one corner. These are the differences. I think more we can share through our website. There is also a lot of reading and references material on our website.
Okay, thanks, Pradeep, for answering that. So the next question that we have here, what if I have already connected some of my equipment to LIMS and ELN, and how do I get started with the STARLIMS SDMS?
Okay. So this is a quite common case where most of the labs would have already connected some of your equipments. I think if you're looking forward, if you're looking for a future-proof solution, instead of having bits and pieces of integration done everywhere and then continuously monitor and manage them, we would recommend this is the right time that you look forward and have all your interfacings migrated to a single source. When we do a job, when you engage us and when you call us, we have a right consultants who can evaluate your current status, and then we can recommend what is the best way of moving all your integrations into a single platform. Yes, that is a job to done, but we have a capability, we have the skill set, and we have the right product to assist you. Depends on where you stand today and where you can go in the lab automation.
Okay, thanks, Pradeep. The next question, how much time and cost does it take to implement STARLIMS SDMS?
Okay, so looks like this question is again for me, Jason. I would take again. I think it's a very obvious question. So I would again put it in a different perspective. The STARLIMS SDMS system is designed as more of a technology solution with less than 5 screen user interfaces, and works more as as a middleware, works on behind the screens. So that helps you very quick implementation. When I say in a record time of implementation, and required very less user trainings, less validation efforts significantly compared to other traditional systems. An average size of the lab, say 30 to 50 equipment size with a one third-party systems integration, would probably take 3 to 4 months compared to 8 months, 10 months, 12 months of integration projects that you run today. That's something I can imagine. And also, the system is designed to offer very flexible licensing model, both in terms of equipments based as well as integration based. So you can start with a very low capex, and you can add on the additional integration capabilities as your lab grow. In other words, you can start with very low capex. Once again, I request, if you have any specific requirement, please reach out to our regional sales and business teams for quick proposals, business consultation, and the pricing for you.
Thanks, Pradeep and Jason. So that's all we have time for today. Any unanswered questions will be responded to via email. I'd like to thank you all for joining us today. And as you leave the webinar, a survey will appear on your screen asking you to rate the webinar. Please take a moment to provide your feedback. On behalf of Abbott Informatics, I'd like to thank you all for attending today's webinar, and we hope to see you all again soon. Goodbye.